Okay, so hello people, today we'll be solving LeetCode daily question 823, which is binary tree with factors. In this, we'll be given an array of unique integers where each integer I will strictly be greater than 1. Okay, and using these integers, we have to create a sorry for that. We have to make a binary tree, and each number may be used for n number of times. Okay, so we can use a particular number n number of times. Okay, and we have to return the number of binary trees we can make. So binary tree with facts, but basically it states that and each number may be each non-leaf node value should be equal to the product of the value of its children. Okay, so let's say we have a binary tree. uh, okay, let's first understand the test cases only. Like in the example one, we will be given two elements that will be 2 and 4. So we can make a binary tree of just these using these nodes. Otherwise, what we can do, we can make, okay, let me, okay, color of this is, then, okay, let me just do one thing, black, and then, yeah, let's say we are having this node. Let's deal with this first. Okay, let's say we are having this node, and in this we are having what value as 4. Okay, so here we are having 4, and what we can do, let me just strengthen this a little bit. Yeah, and the possible tree which we can form is okay. Hmm, okay, just a second. Okay, this again doesn't work. Sorry for the delay. Yeah, this works. Now let me just add an arrow uh, here, and another arrow. This. Okay, so what these two nodes will be having will basically be 2 and 2. Okay, 2. Let me place it here, and another text box, and 2. Okay, so this is one possible binary tree. Other the possible binary trees are we are just using this 2 alone. Okay, and otherwise we are using just this 4 alone. Okay, so this is how we have to tell which are the all the number of possible binary trees. Okay, so in this case, let's say for example we are having 2, 2 will be alone, 4, 5, 10. These are going to be individually also a binary tree. Except for that, we can again make 4 2 to binary tree. Then what we can do, we can use 10, 2 and 5, because let's replace it with 10, as 10 will be product of this 2 and this 5. Okay, so this is one of the possible binary tree, because the non-leaf node, this which is the root node, it is a non-leaf node, is product of its children. Okay, so let's say for here it could also be possible like 5 and 2. So the total number of possible matrices which we can form is 7. Okay, so let's look at the pseudocode for this, how we'll be approaching this question. We firstly what we'll be doing, we'll be sorting the given array, so that the finding the number of factors will be an easy task for us. Okay, so let's first sort the array. I don't know what's the name of the array that is given. It's ARR. Okay, sort ARR. Okay, so firstly we'll be sorting the array, and then we'll be using a set data structure. Okay, set, and we'll be set of let's call it set only. It will be equal to set of ARR. Okay, so we'll be adding all the numbers into the set. Then what we'll be doing, we'll be initializing a hash map data structure, let's say dp, to keep the track that whether the number has been already used or not. Then what we'll be doing, in the set array, no, let's okay, for okay, for I equal to 0 to I less than length of ARR. What we'll be doing, we'll be doing dp dot put ARR I comma 1. Okay, so this is what we'll be doing, and then what we'll be doing, we'll be using two nested for loops. Let's say for I in ARR, then similarly for j in ARR. Okay, so this will be doing to for the dynamic programming. Okay, so what we'll be doing, that firstly we'll be checking that if j will be greater than square root of I, it means that it can't be a possible factor for this. So what here we'll be just breaking the for loop, because from here as the array is sorted, no further element will be the vector for that. Okay, so then we'll be checking that if I mod j is equal to 0 and set dot contains I by 2, I by j, sorry. Okay, so for let's say the example for 4 and 2, we'll be checking that if 4 divided by 2 is equal to 0, which will be true, and then set will also be containing 2. Okay, so this means that it will be a possible binary tree, and what we'll be doing, we'll be calculating the product to add all the possible values of it into that. We'll be doing product will be equal to dp dot get j multiplied by dp dot get I by j. Okay, so and then what we'll be doing, we'll be doing dp, then we'll be again updating the value dp dot put I comma, then here we'll be checking that dp dot get I plus if I by j is equal to j, let's say for example 4 by 2 will be equal to 2, so in that case we'll be adding the product. Otherwise what we'll be doing, product into 2. Okay, so this is how we'll be adding. Then after this we'll be having the updated dp array. Then for the last step we'll be calculating the final result. That means we'll be adding all the values from the hash map data structure. Okay, so okay, and then let's create a variable. Result will be equal to 0, and then for I in dp dot values, what we'll be doing, result will be equal to result plus val I, sorry, okay, I. Okay, and at the end what we'll be doing, we'll be just returning the total number of possible binaries. Okay, so this is how we'll be approaching the question. Now let's move to the coding window, and let me zoom in first. Okay, as in the question that the answer may be large, so we have to return the modulo. So what we'll be doing, we'll be firstly declaring mod as, and let's say int mod will be equal to, let's first typecast it into int 1e9, 1e9 plus 7, I guess it was, yeah, 10 to the power 9 plus 7, yeah, 1e9 plus 7. Okay, then arrays arrays dot sort arr. Okay, then set of integer set will be equal to new hash set, and here we'll be passing set dot of I guess now set of arr. Okay, so I guess that this is, will just let me try with arrays dot as list. Okay, this is the direct method from which we can create an array or a set from the array. Then what we'll be doing, we'll be initializing a dp array with integer comma not dp array, a dp hash map. dp will be equal to new hash map, and then what we'll be doing, for and I and arr dp dot put I comma 1. Okay, this tells that every element is occurring at least once, because in the answer the individual will be also counted, okay, as a binary tree. Okay, the elements individually will be also counted as binary tree. Okay, so now after this, for okay, just let me add a space between here. Yeah, for and I and arr, and then again nested for loop int j and arr, checking that if j is greater than math dot sqrt I break. Otherwise, we'll be checking that if I mod j is equal to 0 and set dot contains I by j, what we'll be doing, we'll be having a variable, let's say long product. Oh, let's call it prod only. Okay, will be equal to, we'll be typecasting it first in the long dp dot get j into dp dot get I by j. Then we'll be updating the value dp dot put I comma, let's typecast it in it to int dp dot get I plus I by j is equal to j. If this is true, then we'll be adding product. Otherwise, what we'll be doing, we'll be doing product prod into 2 basically. Okay, and then we'll be just simply, okay, we need to do the modulo also. Let me just add one more bracket over here. Okay, so yeah, here, yeah, here let me do the mod. Okay, so after this, the for loops, let's initialize a variable, let's say result will be equal to 0, and then a for loop for int val in dp dot values. Okay, so we'll be doing result will be equal to result plus val. Here we have to do the mod. Okay, and then we'll be returning a result. Okay, so let's submit it. This result, it's running. Okay, cannot infer type arguments. Okay, let's just add them manually only. Okay, for and I in arr set dot add I. Oh, okay, it's network error occurred. Try reloading the page. Okay, I don't know why this happened. Let me just reload. My internet is working fine. Mm, okay, let me do it run manually. Okay, so basically lead code is down now. Uh, okay, so okay, so that was it for today. I'll be dropping the code for this code in the comments or in the description, so you can check it out from there. Okay, so thank you for watching.